Hello everyone, I'm Kinjal Patel, Assistant Professor at LJ Institute of Engineering and Technology in the Department of Computer Engineering. So here is the Chapter 2 Lexical Analyzer Lecture 4, in which we will learn conversion from regular expression to DFA using syntax tree method. In previous videos, we have learned how to convert regular expression to DFA using Thompson's rule and subset construction method. And in this video, we will learn the second method, which is syntax tree method for the conversion of regular expression into DFA. So I'll explain it with example. So here is the regular expression A or B clean star ABB. Now before applying syntax tree method, we need to augment regular expression with hash if it is not given. So in the exam, if hash is not given in the example, then you need to add hash at the end of the regular expression. Now, first step to apply syntax tree method is to construct syntax tree. So first we will construct syntax tree for A or B. Now to construct syntax tree in this method, we need not to see or check for the priorities of operators. We will start from the left to right, and only thing we need to consider is that bracket, that we need to perform the input symbol for the we need to perform syntax tree for the input in the brackets first. So first here you can see that A or B are in the bracket. So first we will perform the syntax tree for A or B and then for the clean star. So OR has two child A and B. Now we will perform the clean star of OR A and B. So here you can see the clean star OR A and B. Now we need to concatenate A or B clean star with A. So here dot node is used to concatenate A or B star with A. So now we will use dot node with A to concatenate with A. Now again in between A and B there is also dot node to concatenate A and B. So again we will use dot B. Then again we will use dot B to concatenate with B. Then again we will use dot to concatenate with hash. So here you can see that we have performed the syntax tree, or we have drawn the syntax tree using from left to right. Now what will we do? We will give position to each input symbol. We'll give position to input symbol only, not the operators. So there are 6 input symbols, so we will give position from 1 to 6. So A has position 1, B has position 2, A has position 3, B has position 4, B has position 5 and has hash position 6. Now the next step is to find nullable node. So in this figure or in this example, you can see that the nullable node is clean star. Why clean star is a nullable node? Because clean star is the only operator which produces the null string. Now third step is to calculate first position and last position. First we will calculate first position and we will denote first position with red colored font. So first rule to find first position is, if our node is a leaf node, so which are the leaf node in our example? A, B, B and hash. So if our node is a leaf node with position I, then what will be the first position for that node? I will be first position for that node. So here you can see that our first node is A, first leaf node is A and it has position 1. So 1 will be the first position of A. Okay, now second node is B, which has position 2. So first position for B will be 2. Now third leaf node is A, which has position 3. So first position of A will be 3. And fourth node is B, which has position 4. So first position of B will be 4. And B has five position 5. So first position of B will be 5. And hash 6 position. So first position of hash will be 6. Now the next step is to find the first position for OR operator. So the second rule is for OR operator, that if we want to find the first position for OR operator, then it will be the union of first position of C1 and first position of C2. Here you can see the OR node. So assume that C1 equals to A and C2 equals to B. So union of first position of A and first position of B will be added into the first position of OR node. So 1 and 2 will be added into the first position of OR node. OR node will always have two child node. So union of first child, union of first position of first child and union of will be done with the first position of second child. Done. Now third rule is for star node. So for star node will always have one child only, and the rule to compute first position for star node is first position of C1. That if you want to compute the first position of star node, it will be the same as first position of its child. So we will just copy down the first position of its child in the star node. So here star has one child OR node which has position 1, 2. So directly 1, 2 will be added in the star node. Now next node is dot node. So here is the rule for dot node. Dot node will always have two child. So here is the rule that in dot node we will need to check that its first child is nullable or not. If its first child is nullable, as you can see in the rule that if nullable of C1, then first position of C1 union first position of C2 will be performed. So here we already know that star is a nullable. So A or B clean star will produce the null string. So if nullable of C1 will be performed, that yes, nullable C1 is nullable. So first position of C1 will be union with the first position of C2. So here the dot node has a first child and it has a 1, 2 as a first position, and second child has a first position 3. So 1, 2 and 3 will be added in the dot node 1, 2, 3. Okay, if first node is not nullable, then what will be performed? Then we will just copy down the first position of first child, which is C1. Now we will find the first position for the second dot node. So second dot node, now we will check for the nullable of C1, that C1 is nullable or not. So here the C1 child is the whole subtree which dot has, that A or B clean star dot A. So here A or B clean star is nullable, but it is concatenating with A, which is not nullable. Here you can see that A is must in this string. So in C1 A is must, so C1 is not nullable. So we will perform the else loop, which is saying that first position of C1. So in this dot node, first position of C1 will be directly copied down. So here you can see that directly first position of C1 we have write down. Now the next step is to find the first position for third dot. So in third dot, it will be also as the first position of first child. Why? Because already we know that first child has a must A. Now for this dot, what will be the C1 child, A or B, clean star dot A dot B. So in this string, C1 has A and B as a must. So it is not nullable. So if it is not nullable, then we will just copy down the first position of C1, which we have done. Now the last dot, fourth dot. So also fourth dot has A, B and B must string. So it is not nullable. So if C1 is not nullable, we will just copy down the first position of C1. So first position of C1 has been found. Now next step is to find last position. Now last position we will denote with the green colored font. The first rule to find last position is, it is same as the first position, like leave with position I, then the last position will be I. So here you can see that our first node has a position 1. So last node of last position of A will be 1. Then B has a position 2. So last position of B will be 2. Then again A has a last position, A has a position 3. So last position of A will be 3. Then B has a position 4. So last position of B will be 4. Then B has a position 5. So last position of B will be 5. Then hash has a 6 position. So last position of hash will be 6. Now the second rule is for OR operator. It is also same as the first position. Just the difference is that we will make union of last position of C1 and last position of C2. So here is the OR operator, and we want to find the last position of OR. So it will be 1 and 2. Now the third rule is for star node. So here you can see that star has one C1 child. So the rule is we will copy down the last position of C1 in the star node. So last position is 1, 2. So we will copy 1, 2 in the star node. Now next operator is a dot node. So the rule is same, that if nullable of C2. Now in last position we will check for the second child. So if nullable of C2, last position of C1 union last position of C2, else last position of C2. Okay, so here we will check for the second child. So for the first dot, here you can see the first dot. So first dot has a second child A. So A is not nullable, as in this string A is a must. So A is not nullable. We will perform the else part, which is last position of C2. And last position of C2 is 3. So 3 will be added in the last position of first dot. Now for the second dot, we will check that it has a child C2 which has last position 4. So C2 is not nullable. So again, we will perform else part, which is last position of C2. So 4 will be added in the last position of dot. Now for the third dot, so again, third dot has B child, which is not nullable. So the last position of B will be added into dot. Now again, the last node, which is fourth node. So it has C2 as a hash. So hash is not nullable. So its last position will be added in the last position of fourth dot. So last position also has been found. Now here is just summary of all the rules, that if our node is labeled with null, then obviously nullable will be true. and first position for null node will be 5 and last position for null node will be 5. Now if our node is a leaf node with position I, then first position is I and last position will be I. Then if OR node, then OR node has two child C1 and C2. So first position is first position of C1 union first position of C2 and last position is last position of C1 union last position of C2. And nullable can be C1 or nullable can be C2. Then for the dot node, so dot node has two child, so we will check that if nullable of C1 is true, and if it is true, then we will make union of first position of C1 and first position of C2. Else we will just add the first position of C1. And same for the last position, just we will check nullable of C2 instead of C1, and we will add last position of C1 union last position of C2. Else means if C2 is not nullable, then we will add last position of C2 instead of C1. Here see the difference between first position and last position, that here first position of C1 will be added and here last position of C2 will be added. And the last rule is for star node, that star node is nullable, so here nullable is true, and in the star node first position of C1 will be added and in the last position of C1 will be added. Now the next step is to find follow position. So to find follow position, focus on the first dot at the top. Okay, so I have just copied down this part in the square box. So here you can see our C1 child and C2 child and the dot node. So here dot is C1 child and hash is C2 child. So there are two rules to find follow position, which are for dot node and star node. There is no rule for OR in finding follow position. So there are only two rules. One is for dot node and one is for star node. Now we are starting from dot node. So here see that last position of C1 is 5. Okay, and first position of C2 is 6. So from this, we can find the follow position of 5. So follow position 5 will be 6. So follow position of 5 equals to 6. So here we will also maintain one table for follow position. You can see that follow position of 5 is 6. Now focus on the second dot. I have just copied down this part in the square box. Now here last position of C1 is 4 and first position of C2 is 5. So we can find the follow position of 4 from this. So follow position of 4 will be 5. That follow position of 4 is the first position of C2. Okay. Now you can see the changes in the table, that follow position 4 has follow position 5. Now focus on the third dot. Okay, now this dot has a child C1 and C2 and last position of C1 is 3 and first position of C2 is 4. So follow position of 4 will be added into follow position of 3. So follow position of 3 will be 4. Okay, so follow position of 3 will be 4. Now focus on the last dot, which is our fourth dot. So follow position of this last dot is 1, 2. Here you can see 1, 2. Now last position of C1 is 1, 2 and first position of C2 is 3 and this dot has first position 3. Okay, so next follow position of 1 and 2 follow position of 1 and 2 will be 3. So follow position of 1 equals to 3 and follow position of 2 equals to 3. So 2 equals to 3 and 1 equals to 3. So we have applied this first rule for all the dots. Now we'll apply second rule, which is for star node. So I have just copied down this star part in the square box. So for the star node, see the last position of that node. That last position is 1, 2 and first position is also 1, 2. So this last position are our position. So from this last position we can find this position. So here position is 1 and 2 and one position has the follow position, which is first position of star. So first position is 1, 2. So in one node follow position of 1 will be 1 and 2. Follow position of 1 will be 1, comma 2. Same, this is the last position. So also there is last position which is 2. So follow position of 2 will be whole set of first position of star. Follow position of 2 will be whole set of first position of star and follow position of 1 will be whole set of first position of star. So follow position of 1 equals to whole set and follow position of 2 equals to whole set. So now you can see that 2 has follow position 1, 2 and 1 has follow position 1, 2. So follow position has also been found. Now the last step is to construct DFA from this follow position. Now we will just analyze the follow position. Here you can see the table which has position and its follow position. These are the input symbol which was given in the regular expression. That our regular expression was A or B clean closure dot A dot B dot B. So these are the input symbol which we have given the position. Now what will be the first starting state for the DFA? So first position of root node in the syntax tree will be our starting state. Here you can see that first root node is a dot and it has first position 1, 2, 3. So 1, 2, 3 will be our starting node, which is A. Now state transition table. So A is a starting symbol. Now what we want to find, we want to find capital A on transition A, which will be the union of follow position. Capital A on transition A, which will be the union of follow position. Now follow position of which position? So it depends on the input symbol you are finding. Like you are finding 1, 2, 3, comma A. You are finding 1, 2, 3, comma A. So here our input symbol is A. So we will find that from 1, 2 and 3, which number represent the A input symbol. From 1, 2 and 3, which number represent the A input symbol. So here you can see that position 1, 2 and 3 and 1 and 3 numbers represent the A input. So union of follow position of 1 and union of follow position of 3 will be added in the function. So 1, 2, 3 union for which is 1, 2, 3, 4. So new state B has been generated. So A on A is B. Now the next step is to find the A on B transition. So here you can see that from now what we need to find that from 1 to 3, from position 1 to 3, which position represent the input B. So here you can see that 2 represent the input B. So the follow position of 2 will be added into function. So which is 1, 2, 3, and we'll compare it with the previously generated state. So it will be matched with the 1, 2, 3. So it is same as a state A. So we'll name it as a A. So A on B is A. Now the next task is to find the state B on transition A. So we will find from 1, 2, 3, 4 node which node represent or which position represent the number A. So 1 and 3 position represent the number, position represent the input A. So union of 1, follow position of 1 and follow position of 3 will be added, which is 1, 2, 3 union 4. So 1, 2, 3, 4, and we'll compare this node with the previously generated node. So it is same as a B, so we will represent it as a B. So B on A is B. Now next we will find the transition B, that state B on B transition. So follow position of 2 union follow position of 4. Why 2 and 4? That from 1, 2, 3 and 4, 2 and 4 represent the B input. So follow position of 2 and 4 will be added in the function. And 1, 2, 3, 5, we will compare this 1, 2, 3, 5 with the previously generated state. So it is not matching with any of states. So we'll represent it as a new state C. Now next we'll find the transition for state C. So it will be 1, 2, 3, 5, comma A. So we'll find that from 1, 2, 3, 5 which state represent the input A. So 1, 2, 3 and 5. So only same as above, that 1 and 3 only represent the input A. So it will be same as the above. So 1, 2, 3, 4 state has been generated and it is same as the previously generated state. So we will represent it as a B. Now we will find the 1, 2, 3, 5, comma B. So follow position of 2 and 5 will be added as from 1, 2, 3 and 5. 2 and 5 represent the B. So follow position of 2 and 5 will be added, which is 1, 2, 3, 6. And it is not matching with the previously generated state. So we will name as a new state T. So state C on B is T. Now the next state is T, 1, 2, 3, 6. So from 1, 2, 3 and 6 is the hash node. So we will ignore it. So we are just finding the 1, 2, 3 follow position. So from 1, 2 and 3 which represent the A and B. So A1 and 3 represent the A and B. So we will just add the union of follow position of 1 and follow position of 3, which is B. Now next task is to find the D on state B. So D on transition B. So from 1, 2, 3, 6, 6 is a position of hash. So from 1, 2, 3 which represent the B input. So from 1, 2, 3, 1 and 3 represent the 2 represent the B transition. So it will be the 1, 2, 3. And it is same as the A node. So here we will write A. As we are ignoring 6 in the state D, so it will be the same as a state. So it has the same transition as A has, like BA and BA. Now we'll construct DFA from this. So here starting state is A and A on A is B and A on small b is A itself, then B on A is B itself and B on B is new node C, then C on A is capital B and C on small b is capital D, then D on A is state B and D on B is state A. Done. Now, which will be the final state? So, our final state will be D. Why? Because the state with the position of hash will become the final state. And the position of hash is 6. So, state D is a final state. 6 is available in the state D and 6 is the position of hash. So, 6 will be the final state. The final DF has been generated using syntax tree method, in which we have applied the or find the first position, last position and follow position. Thank you.